I'm really happy to welcome Mélanie once again, and this time with Stéphane Bégaudeau, the main architect of Obeo Cloud Platform, OCP. And I think they are eager to present what they have developed recently.
Thanks, Samuel. So, hello again, I'm still Mélanie Batz. I'm very pleased to present this talk with Stéphane Bégaudeau, the software architect of the Obeo Cloud Platform. How are you, Stéphane?
I'm doing great, and you?
Great. So, we can start. To get started, a quick reminder on the basic principles of Sirius. First, you define a metamodel thanks to EMF. Then, you provide a Sirius configuration to specify the mapping between the different concepts of your DSL and how they should be represented graphically. As a result, you get a graphical modeler dedicated to your DSL, a workbench for your end user. Currently, we contribute Sirius as an open source project. With the Obeo Designer Community Edition, you have all you need to work with Sirius and create desktop graphical modeling workbench. Today, we provide also the Obeo Designer team for organizations needing real-time collaborative edition in Eclipse-based workbenches. The main issue faced by our customers arises when they need to distribute the bundle to their end users. A truly effective deployment is complex and difficult to achieve. Many struggle to either deploy or maintain their solution, and their team are feeling the pinch. To solve these challenges, we decided to develop the Obeo Cloud Platform. With the Obeo Cloud Platform, we keep the principles of Sirius. You still have your metamodel as an core, you still define a Sirius configuration. The idea now is not to provide an OCP application, but a web application. Yes, the slide is arriving. Your end users, instead of opening Eclipse, will open the browser to access your modeling workbench. As I already said during the introduction, I'm very proud to announce that we are open sourcing the core of the Obeo Cloud Platform. It will be called Sirius Web. Sirius Web is a cloud-based solution and a cloud-based evolution of Sirius for deploying modeling tools to the web. The first release will be available in October this year if everything goes as expected. So, with Sirius Web, modeling tools developed with Sirius can be installed on a web server and are rendered in a browser. We will provide in parallel the Obeo Cloud Platform for enterprise usage. The Obeo Cloud Platform provides a set of cloud-based technologies for building and deploying modern and online modeling solutions accessible from web browsers. The Obeo Cloud Platform contains two different offers: OCP publication to expose models in read-only mode for fast access from OSLC clients or web browsers, and OCP Modeler to create graphical modeling solutions that can be used collaboratively from a web browser. It provides features dedicated to a professional usage, for example, the capability to have private-public projects, to provide an integration with other web applications, or also the possibility to visualize collaborative edition on shared models. After this short introduction, I will let Stéphane demonstrate the Obeo Cloud Platform Modeler. So, Stéphane, the floor is yours now.
Thank you. So, let's have a look at the Obeo Cloud Platform. So first, we'll get started by logging inside of the system. So I will log as John Doe. And now I arrive on the project list, where I can see all the projects that I have created. I can create new one or upload existing one that I've downloaded before. I can also delete existing project if I want to. So here, let's create a new one for SiriusCon. I will make this project a private one. I could use a public one too. It will be accessible to all users, but this one is only mine for now. So let's make it private. Once the project is created, you will arrive on the workbench. Here you will see the Explorer on the left, the properties on the bottom, and in the center, your representation when you will create and open one. So to get started, I will upload an existing EMF model that I've created before. So this model is a simple flow model. If I open it in VS Code, you can see that it's a regular EMF model that I will upload now. So once uploaded, my model will appear in the Explorer on the left. I can navigate inside of my elements, and once an element is selected, you can see its properties on the bottom in the properties area. From there, I can create new representation. So here I'll select the system element, and I have 3 different kinds of representation that I can create, and I'll start with the topography one. So right now, I can see a very simple flow diagram, and let's talk about this flow domain for a minute. So in flow, you can have systems which contain other subsystems, and you can have some hardware components such as radar or camera as data sources. You can also have fans and CPUs to send and receive data between various components. So this way, you can design a simple hardware solution with the flow of data between the various elements. So when your diagram is open, it's not just an image. You can select element, you can zoom in or out. If you want, you can fit the whole diagram on the screen at once. You can also edit it thanks to the palette on the right, also the contextual palette when you click on an element, or in the Explorer on the left. So let's get started by creating a new composite processor. And I will rename it to, I don't know, Media Center. And inside, I can create a processor. So this processor, I won't edit its name directly in the diagram this time. I will change its name using the properties. So let's name it GPU. And I will connect it to another component. And you can see that the layout of the diagram is updated automatically to have a nice looking diagram. So we are providing an assisted layout to help you see nice looking diagrams at all time. So now let's add a new data source from the Explorer. Here, it doesn't have a name, so it will be the front camera. And I will connect it to my GPU. And you can see that we have a nice looking diagram. So on top of that, we still have a dynamic diagram which can evolve if we change some properties of the elements displayed. So if I try to change the status of my GPU, you can see that its color will be updated. I could also change its capacity to make it grow bigger or smaller, because its size is computed from this capacity. So with all those features, you can edit your diagram fairly quickly while staying in your web browser. We can also download the model. And if we go back here, you can see that we have the new model with the front camera and the media center component that we have created. And this is a standard EMF model, so you can bring it back into Eclipse or any other modeling tools which are compatible with EMF, such as Sirius, to work with those same files. So it's quite easy to bring files inside of Obeo Cloud Platform and outside of it. Okay, so now we've seen a simple diagram. Let's have a look at how it's created and how do you move from a Sirius diagram to an Obeo Cloud Platform. So for that, let's get back into Eclipse. As Mélanie and Pierre-Charles said it before, when you get started with your Sirius project, you start with an eCore meta model in which you will define all the concepts of your domain. So here you can find the processors, the systems, we still have the fan and the data sources that we have manipulated inside of Obeo Cloud Platform. On top of that, in order to define the diagrams, we can create a design definition which will contain the description of all the diagrams that will be available. So here we can see our topography diagram, and inside we will retrieve the definition of all the concepts which will appear on screen. So for example, the system is defined with its style, its contents, the data source too. And this definition language to help you specify your diagram is completely generic. You can define any kind of diagram with it. It's not specific to this flow diagram. So here you can see that for the data source, we have decided to say that it will be rendered thanks to an image. And if the name of the element changes, then we will use another picture instead. We can also say quite easily that our system has a default style, but if the temperature of the system is modified, we can change its appearance. So here we have defined that if the temperature is above 40 degrees, it will have a red border, and if it's between 30 and 40 degrees, it will have an orange one. So if you try here, for example, on the capture subsystem one, and if I modify the temperature, you can see that we now have this orange border. And if I use 50, we have the red border, but it's not very visible. So I'd like to make something which can be viewed much more easily. Let's modify this in the ODesign file. So for that, I can change the background and foreground color if the temperature is between 30 and 40 degrees to be orange and light orange too. And if it's above 40 degrees, it will be light red. Like that. I know that I have some small error somewhere else in my ODesign file, so Sirius will warn me that there is a problem, but it does not matter in this demo. So now that I have my eCore model, which is a standard EMF project, and my flow.odesign in a standard Sirius project, I need to bring them into the web. For that, I can build both projects with Maven and produce a Maven repository, which I can use in my Obeo Cloud Platform project. But since it can take a couple minutes, I will use an alternative way to do that. Now, let's have a look at the project by itself and how to start an Obeo Cloud Platform project. So here we have a very standard Spring Boot application with a couple of Java files that you need to get started. First, we have the entry point of the application, which is just a main method telling Spring to run our server. Nothing exotic here. The initializer has been created for the demo to create an account for Joe and for another user. So no need to spend a lot of time here. Then we have the EMF configuration. This is used to tell Obeo Cloud Platform the meta model that you want to use and how they can be manipulated. If you're familiar with EMF, it's quite easy. You just need to register the ePackage and adapter factories for your meta model, and then we get started. Finally, you have the Sirius configuration, and this is where you will reference the path of your ODesign files. So if we have a look in our Maven dependencies, you will be able to see that we are using both the eCore and the ODesign in our dependencies, and we just need the path of the ODesign file here. Finally, there are two other services. This one is to tell us the path of the images inside of your ODesign project, and that one is to contribute default models into Obeo Cloud Platform. So now let's pass here our ODesign, and I will shut down the server, which is trying to restart already because I've modified the content, and I will rename this ODesign not to have a conflict with the existing one. And I will tell Obeo Cloud Platform to look for flow_new.odesign, which is the name of this other one. I can restart my server. And then we will see how the new rules, so the background should be now light orange if the temperature is between 30 and 40 degrees, and light red if it's above 40 degrees. We'll see how those new rules are taken into account. So the server is up and running. So yeah, I need to log in once again. So I'll create a new project, Flow Demo. Here you have the sample models I was talking about, and let's create a topography diagram. So here, the central unit, if I change the temperature to be 35, and if everything is working, you can see that the background is now orange. And if I go to 50 degrees, you can see that everything is red. So you can see how you can bring an existing Sirius project into Obeo Cloud Platform. That's quite easy. You keep your existing meta model, you can reuse your ODesign, and you just create a Spring Boot project to get started with this. So I've shown you this flow example. Let's have a look at another kind of diagram, because as I said earlier, this is not specific to flow. In fact, we can have a look at another meta model. Here we will look at BPMN. BPMN is a meta model which defines concepts for business processes, and we have the definition of its diagram too. So if we have a look at this here, you can see on the top left the concept of flow with processors and fans and the definition of the flow diagram. And on the bottom left, you have the concept of BPMN with this time messages, you have interactions, tasks and activities, you have events. So it's a completely different domain. And we have this time another definition of diagram, the process diagram, which defines how those concepts will appear on screen with some different images and other appearance. So let's have a look here. We'll create a BPMN project with a default BPMN model, and we'll create a process diagram on it. And you can see here that we are on a completely different diagram. Nothing is the same. We have a different palette with new tools, we have new concept, and we have a new appearance for a diagram. So Obeo Cloud Platform, just like Sirius, is completely generic, and you can edit your domain with the diagram of your choice. But those two models here, the Noble one and the Flow one that I've shown you before, are quite small. So we are also working with larger model. So when I started the demo, I've imported this flow.model, which is 3 kilobytes. Now we will have a look at this mega factory model, which is 55 megabytes with 350K elements inside of it. And we can navigate inside of it in the Explorer quite easily, could also navigate with our keyboard if we want to. It has been created programmatically, so it does not represent a real complex system, but it has the same size as some models from our customers. And we could even have a look at other diagrams that we have created. If I go back just for a minute to our flow or design, you can see that we have multiple diagrams inside of it. So let's have a look at a dependency control diagram, which is a bit smaller, but we could also create another diagram, a topography one. So you can see that we have something way different this time. And we are working with this large model with multiple diagrams on various elements without issues. Simplify topography. Yeah. So here we have 3 diagrams on the same large model, and we don't have any problem with that. But now I'm working alone, and it feels a bit lonely. So it's time to have a look at what's going on when you have multiple persons working on Obeo Cloud Platform. So for that, let's go back to the Flow demo, which is my private project here. And I want to invite somebody else. So here I have a first web browser, which is Google Chrome, and I have another one, which is Chrome Canary. And this time, Alice will join to edit my diagrams. So she can't see any of my projects because they are private. So first of all, I need to share this project with her. So I'll have Alice as a viewer of my project. And I refresh. She can now have a look at my project. So I can open the topography diagram, but as you can see on the right, it's all grayed because she's only has the right to view the diagram. She can't edit it, so it won't be very funny. Let's give her the admin right. And if I reload the page, okay, now I will be able to edit my diagram. So it's Flow demo. So now I will have my 2 users working on the same diagram. Since they are both opening the same diagram, you will be able to see here that John can see that Alice has been connected. And here Alice can see that John is working on the same diagram. If I'm topography one, as I'm leaving the topography diagram, you can see that Alice can see that I'm not here anymore. But if I go back, she sees that we are working on the same diagram. Just like in Eclipse Sirius, all diagrams are synchronized on the same data. As an example, let's say that here as John, I want to rename the capture subsystem element to say that it's capture subsystem 2. It has been renamed in my properties view. It has been renamed in my diagram and in the Explorer too. And if I switch to my other diagram, of course, it has also been renamed. But it has been renamed on the diagram that Alice is viewing and on a view of the Explorer. So both users can work at the same time on the same data. So now if Alice is viewing this capture subsystem object while John is doing the same thing, you can see at the bottom in the properties that John can see that Alice is working on this capture subsystem object, and Alice can see John, even if they are not in the same representation. Topography for Alice, simplified topography for John. But it does not matter. They can still collaborate. If John tries to rename this capture subsystem object, Alice will even be able to see that John is currently modifying the name. Is currently focused on the name, for example, to rename it to capture subsystem 3. And if John wants to change the temperature to 50 degrees, you can see that Alice will see the changes in real time on her diagram, even if John's diagram has been updated, but it does not care about the temperature. It's not displayed in this one. So both users will be able to see the impact of what they are doing with a real-time collaboration support, a bit like in Google Doc, but across multiple diagrams. All your diagrams are synchronized on your data, but they are also synchronized for all the person who are working with you on the same project. That's it for the demo. Let's get back to the slide.
For information, 4 minutes remaining.
Yeah, I know. Thanks, Stéphane. So to conclude, remember that the Obeo Cloud Platform provides a set of cloud-based technologies, OCP Modeler for building and deploying modern and online modeling solutions accessible from web browser for enterprise, OCP Publication to expose model for OSLC clients, and Obeo Cloud Platform, so OCP, is built as an open core product relying on Sirius Web. Sirius Web will be available in October this year if everything goes well, as I said, and will be 100% open source. Thanks for your attention. If you have any question, we will stay with Stéphane in this room for several minutes, so do not hesitate to join us. And do not forget, I'm counting on your help to have a great Ask Me Anything session later today. So go to menti.com, use 703162 code, and ask your question about Sirius Web or anything I can answer. Thanks.
Okay, thanks, Mélanie. Actually, we have a lot of questions. A lot of them has already been answered on the forum, but okay, we can discuss them anyway. The first one is, do you define the domain-specific representation on the web interface or in the desktop version of Sirius?
On the desktop version today. For the specifier, nothing changed. Everything is in Eclipse.
Okay, thanks. What kind of web framework used in Sirius Web?
Fairly standard solution. So on the backend, it's Spring Boot with a GraphQL API, and on the front end, we have React.
Okay. I think you just answered the next one. Is Sirius Web open or licensed?
Sirius Web is open, as I said, which is licensed is OCP, so Obeo Cloud Platform, and one will be available. You can in October. You will be able to try it, and OCP is already available today if you want to try it. It will keep some enterprise features, for example, like the collaboration you just see right now in the demo would stay in OCP.
Okay. Does the cloud version provide more types of diagrams and predefined visualizations?
Currently, we're not providing more types of diagrams, but we have worked to be able to provide new ones.
New kind of representation, yes.
Okay, and probably the last question for me, but you can continue to answer them after. Can you work collaboratively on such models?
Yes, as we show, it's possible, definitely. Alice and John Doe work together on the same model, so yeah.
That's rephrasing the questions. Okay, so thanks for this great presentation. I will prepare the next one, but once again, you can continue the Q&A session.